Hello and welcome back to Fun and Games with the CPU Simulator. In the last video we configured the CPU Simulator to output the United Kingdom traffic light sequence. This worked well. We got the traffic light sequence pretty much correct, but the problem was it was transitioning very fast. It was transitioning fast in general, but that relates to the clock speed. We can actually slow that down. If we slow it down to 1 instruction per second, then it looks about right speed-wise, but the problem was where we had the red-green light sequences. The red-green light sequences, we need to have some form of delay there in order to allow the traffic to flow. And that's what we're going to look at in this video. So without further ado, we'll load up the CPU Simulator and we'll open the code that was used in the configuration from the last video, which was test_lights, I believe. That looks good. Okay, so what have we got? We've got start, then we've got different sections: red, green, red, amber, red, green, red, amber, red, and red, amber. We've got a move into the general purpose AL register, the hexadecimal values that give us those colours, red, green being 84, red, amber being 88, and then we've got the output command to output to 01, which is the traffic light output, which will output those specific hexadecimal codes to the traffic light output and generate the correct light sequence. And if we run this, we get the correct traffic light sequence. The problem is it's a bit fast. Now we can slow it down. So if we just slow it down so as we're getting about 1 instruction line read a second, which is probably about there, we have a fully working traffic light sequence. The problem is that when we go to red and green like there, and again red and green in the opposite direction like there, we need a delay, and that's what we're going to look at now. There are numerous ways of creating delays, but we'll just do a nice sensible way of doing it for the moment. So we'll stop the program and we'll see how we can create a delay. Right, first things first, you'll notice that in the source code RAM editor the program only occupies a very small part of the source code RAM editor, right up the front here, running all the way from move AL84 out to jump back to start over the side here. The rest of it has the end on there. What we're going to do is we're going to create another little tiny procedure or program which is going to run at the top end of this source code RAM editor to keep it out of the way, and that will use a simple loop which will go around decrementing by 1 until it hits 0, and then it will jump back into where the program was originally running. So it's really just a timing loop. So let's see how we would do that. Smooth the end part down a little bit, and let's see. So first things first, let's create a comment, which is a semicolon. And what does this do? We want a decrement by 1 until value actually reaches 0. This is a standard way of looping. It's in the help files, so you've got examples which mention this, and that's what it's going to do. We'll put this particular program up high in unused memory area. So we've got well, it starts at C0, D0, E0, F0, all the way across to FF, which is right on the other end here. This is all empty, so we'll stick it at F8. It's not a particularly big program, so it should fit in there at F8. So to do that, we'll just do an org, and we'll set it up so as it runs at memory location F8 in the source code RAM. Okay, we'll call it a loop because after all that's pretty much what it is. So loop, and the loop we will use decrement. We'll need to use a different general purpose register because at the moment the AL register is in use. We're using the AL register in the other steps, so we could use the BL register, the CL register, the DL register. They're all general purpose registers. We'll just use the next one that's available. So we'll decrement the BL register, that will automatically decrement that by 1. Okay, and then what we need to do is we need to do a jump if not 0, J and Z, jump if not 0, back to the beginning of this section loop. Okay, so what it'll do is it will take a value, we'll move a value into the BL register, and then as it runs it will decrement that by 1, and it will keep doing that till that value hits 0, and when it hits 0 it will return to the stage of the program that was already running. Okay, so return to the stage of the program you're already running. That looks pretty reasonable. Let's just get the end back in there. So we've created another little section here, and that will appear at F8 over here somewhere when we start to run it. But we do of course need to put a value in the BL general purpose register, and depending on the size of that value will depend upon the delay. Now it's up to you to work out what size you need to give you the correct delay in seconds. I'm not going to give you any information on that, but what we will do is we'll, in the red-green section, we'll start putting a value into the BL register. How do we do that? Well, it's exactly the same as moving a value into the AL register. We just do move into the BL register, a value of, I will just say 6. So it will start at 6 and it will run around that loop, decrementing by 1, so it will go 6, 5, 4, 3, 2, 1, 0. When it hits 0, it will return to the next step. Okay, and we need to call that procedure. Where does that procedure start? The procedure starts at memory location F8. This is why we put org F8, so as it started over here at F8. So we need to call F8. Looking good. Okay, so that's going to put a value in there which will give us a delay. Of course we need another delay, don't we, on the green-red section here, but I'm pretty certain you can understand that that will be done in exactly the same way, but presumably with a different number here to generate a different timing. Let's have a little look, see how that works. Okay, I think that should run now. So run. Okay, so we have red-green. And you will notice we are now bouncing around that loop. Decrement by 1, decrement by 1, decrement by 1. And then it will carry on. Nice little delay there for the red-green. Reaches 0 and then it carries on where it left off. Now we don't have a delay at the moment on the other red-green, but we should do. But that's done in exactly the same way. So you can now see we're in the loop. And you can even look at the BL register value. It started at 6, 5, 4, it's now at 3, then at 2, then at 1. When it hits 0, it returns to where it left off. It carries on running again. Okay, I'll tell you what, let's just do that then. Let's take that number there, drop it into here. Let's just give it a different delay, shorter delay this time. 2, and then we will run it again. Okay, so red green, this will be a long delay because we're counting from 6 down, and the other value will be a shorter delay because we're only counting from 2 down. Okay, now obviously running at 1 Hertz you need to work out what's going to give you the length of delay on the green-red cycles that you want. There we go. That was the short delay. It's back on again. Okay, so that's pretty straightforward. How to create a delay on the traffic light sequence. Okay, so signing out from this video. We probably won't be doing very much more with the CPU simulator. We'll be moving over to some other things. Wonderful piece of software though, well worth playing with.